alternating current. First one, what is meant by alternating current? Alternating current. First, suppose y-axis, on y-axis I am taking current, on x-axis current, on x-axis time, origin. First, suppose if this current is not changing with respect to the time, this is the straight line. Straight line. Current or EMF, voltage, current or EMF is not changing with respect to time. This is called direct current. DC. DC means direct current, no change with respect to straight line. So as time goes on, increases, current or EMF does not change, fixed. This is DC. No change. DC, direct current. This is direct current. DC, direct current. Direct current, its magnitude and direction cannot change. Magnitude and direction cannot change. So straight line means its magnitude and direction cannot be changed. No change of magnitude and direction. Okay, direct current DC, its magnitude and direction, magnitude and direction cannot change with respect to time, no change of magnitude and direction. That's why this is DC. Direct current, fixed, magnitude fixed, direction also fixed, no change. What about alternating current? Okay, on this axis I am taking current or EMF, current or EMF. Okay, this is the time axis, time. First, suppose here as time passes, current increases and decreases, and it also becomes to negative, alternately changes. This is the triangular wave, alternating current, alternating current, one of the shape of the alternating current. Its name is triangular wave. Triangular wave. That means, so this is alternating current. Alternately, it goes on increases with respect to time. Its magnitude changes, direction also changes. So from here to here, its direction is upward direction. Again, its direction changes. That's why this is alternating current. One of the shape of the alternating current. Its shape is called, is nothing but triangular wave, because it is in the shape of triangular wave. So here give some more diagrams for alternating current. All these are alternating current directions. So very important. Now this is a sinusoidal wave. Sinusoidal wave. Actually, this is very important, because in our house it is to be coming. Sinusoidal wave is to be coming to our house through the wires. This is the very important sinusoidal. This is also another alternating current, sinusoidal wave, sine wave. So this is a sine wave. Sinusoidal wave. Here current or EMF, in this direction. This is the sinusoidal wave. This is the sinusoidal wave. Okay, this peak value is nothing but I naught or E naught plus E naught peak value, peak maximum value. This is the peak value. Here in this direction, this is also the peak value minus E naught. So this is the sinusoidal wave. It is also alternating current. Sinusoidal wave, actually in our house, this wave is coming. Okay, direct current means no change of magnitude and direction. So it is not our chapter. These are our chapter. These are alternating current waveforms. Waveforms of alternating current. The upper one is called triangular wave because its shape is in triangle. This is the sinusoidal wave. Sinusoidal wave, it has an equation also. So all having a certain equation, a single equation of this alternating current. Alternating current has an equation. Okay. Some more alternating currents. So here I also am giving some more shapes of alternating currents. So this is also alternating current. Here this is so rectangular wave. Rectangular wave. This is the rectangular wave. Rectangular wave. Alternating current. This is rectangular wave. Rectangular wave. Even alternating current happens. Rectangular wave. So its magnitude also increases, decreases. Another one more also, sawtooth wave. So this is current or EMF time. So this is the sawtooth wave. Sawtooth wave. So this is the sawtooth wave. Just like sawtooth wave. Okay, sawtooth wave. So this is the sawtooth. Sawtooth wave. Okay, all these are alternating current. All these are alternating current. Alternating current. This one is only direct current. Okay, all these diagrams are alternating current. In this, all of these, this is the sine wave. Sine wave, it has an equation. It has an equation. What is the equation of these waves? The equation of these waves, E is equal to E naught sine omega t. E naught sine omega t. This is very, very important equation of alternating currents. E is equal to E naught sine omega t. In this one, E naught is peak EMF, peak maximum. This is E naught, okay, the maximum vibration of the particle, peak EMF. E naught is nothing but peak EMF. This is peak maximum, peak EMF. This is E is nothing but instantaneous EMF. That means it will be changes with respect to time. Instantaneous EMF. This E is instantaneous. Instantaneous EMF. It will be changed. It will be changed with respect to time. In this equation, E naught is peak EMF. E is instantaneous EMF. So this omega t, we know that actually this one is nothing but phase. This is the phase. Similarly, we can also write I is equal to I naught plus I naught sine omega t. current equation I is equal to I naught sin omega t. ఒకసారి చూసుకోండి ఇవి. దీన్ని ఏమన్నాను? డైరెక్ట్ కరెంట్ మీన్స్ in our house DC is not coming, only AC is coming. మన ఇంట్లోకి వచ్చేది ఇది. This is the sine curve. DC is not coming to our house. AC is coming, only AC is coming. Alternating current, it has certain frequency and voltage also. 50 Hz is its frequency, 220 volts. RMS voltage is 220, 50 Hz. 50 Hz is its frequency. Okay, third point. In our house, only AC is coming. Alternating current is coming. Okay, only AC is coming. Frequency 50 Hz frequency. RMS voltage approximately 220 volts. 220 volt. Okay. Next, what is meant by single phase and what is meant by three phase? Okay, ఇక్కడ ఇంకోటి కూడా గుర్తుపెట్టుకోండి. ఇందులో ఈ నాట్ హ్యాస్ ఎ ఫిక్స్డ్ వాల్యూ. ఈ నాట్ మీకు ఆల్రెడీ చెప్పుంటాను. ఈ నాట్ మీకు ఈక్వేషన్ వచ్చింది ఒక చాప్టర్లో. ఈ నాట్ ఈజ్ ఈక్వల్ టు వెరీ వెరీ ఇంపార్టెంట్. ఇక్కడ రాస్తాను. ఈ నాట్ ఇక్కడ కనపడుతుందా? ఈ నాట్ హ్యాస్ ఎ ఫిక్స్డ్ వాల్యూ. దిస్ ఈస్ ద షార్ట్ కట్. ఈ నాట్ ఈజ్ ఈక్వల్ టు BA omega n. BAWN. So B means magnetic field. Area of the coil area. Coil is rotating in the magnetic field. One coil, it has angular velocity omega. For suppose two magnets are there, a coil is to be rotating. Torque ఇక్కడ చెప్పుంటాను మీకు, ఒకసారి చెక్ చేసుకోండి. అక్కడ B, magnetic field. Inside the magnetic field, any coil is to be rotated, electricity is generated, current is generated. So BA omega n, this E naught is BA omega n. భావన అంటారు దీన్ని, గుర్తుపెట్టుకున్నాం. భావన BA omega n. E is equal E naught భావన. B means magnetic field, area of the coil, angular velocity, number of turns. Okay. Inside the magnetic field, if any coil is to be rotated, it creates electricity with an EMF of E is equal to E naught sin omega t. Okay. Very very important. BA omega n. Next one. What is meant by single phase and what is meant by three phase? 3 points over. Fourth point. What is meant by three phase? In our daily life, we hear so many times three phase, single phase current, three phase current. మనం వింటా ఉంటాం. సింగిల్ ఫేజ్ కరెంట్ అంటే ఇప్పుడు మన క్యాంపస్ ఉంది, త్రీ ఫేజ్ కరెంట్, త్రీ ఫేజ్. ఇప్పుడు ఇది ఉంది, దిస్ ఈజ్ ద సింగిల్ ఫేజ్. ఈ బిల్డింగ్ సింగిల్ ఫేజ్ ఉంది, అవతల దానికి త్రీ ఫేజ్ ఉంది. వాట్ ఈస్ మీన్డ్ బై సింగిల్ ఫేజ్ అండ్ వాట్ ఈస్ మీన్డ్ బై త్రీ ఫేజ్? ఫర్ సపోజ్ it is the magnet. This is the magnet. North pole, south pole. Magnets, north pole, south pole. మీకు మూయింకాలు కాలనా మెట్లు కట్ చేసి ఉంటాను, మధ్యలో కాయిల్ పెట్టి దాన్ని రొటేట్ చేయటం అక్కడ చెప్పాను, చూడండి అన్ని. సో దిస్ ఈస్ ద నార్త్ పోల్, సౌత్ పోల్. Cylinder is to be rotating. On this cylinder, only a single coil is to be. So this is the single coil. it is to be rotated. Here, take the output coil. So this is the coil, one coil. Okay, if one coil is rotated in the magnetic field, this is single phase. Single phase. Only one coil is rotated in the magnetic field. One coil. ఒక కాయిల్ అయితే తిరుగుతుంది. ఓకే, సింగిల్ ఫేజ్ only one coil is rotating, only one coil is rotating in the magnetic field. So this is only one coil is rotated. Due to this rotation of one coil, electricity is generated. This is the single phase. First, suppose three phase. What is meant by three phase? Okay, here three coils are rotated in the magnetic field. So this is the diagram for three phase. Cylinder. Okay, so this is one coil, its input and output. So okay, output is taken, current generated, one coil. So another coil is also wound on the cylinder. So this is the secondary coil, output, one more coil also wound. Here three coils are to be rotated at the same time. Three coils. There is a magnet. There are two magnets, north and south. In between these two magnets, there is a cylinder. On the cylinder, three coils are to be wound. If the cylinder is to be rotating, those three coils are to be rotating inside the magnetic field lines. Now, this is three phase. There is an advantage of this three phase. What is the advantage? If any one of these coils fail, the other two are working. వీటిలో ఏదైనా ఒకటి ఫెయిల్ అయింది అనుకోండి, రిమైనింగ్ టూ ఆర్ వర్కింగ్. సో దిస్ ఈస్ very, very important. Three phase means in three phase, three coils are rotating in the magnetic field. In three phase, three coils are rotating. Three coils are rotating at a time in magnetic field. Three coils are rotating. The three coils are rotating at an angle of 120 degrees each. At an angle of, the three coils are rotating at a time at an angle of 120 degrees in magnetic field. That means the angle between any two coils is 120 degrees in this way. So this is the coil 1. For example, coil 1. This is the coil 2. Three-phase diagram. Coil 3. So this is the junction. The angle between any two coils is 120 degrees. So this is 120. These two coils has 120 degrees. Here also 120 degrees. 120 degrees. The total is 360. Complete. 360. Okay, here first the one phase is to be taken in between these two lines, one phase. So this is one phase between these two. So this is the neutral. So this is the second phase between these two. Second phase is to be taken in between these two, phase 2. One phase, two phase. Okay, one phase. Okay, one phase, fine. One phase, two phases are over. This is the third phase. Yes, between these two terminals, take the third phase. One phase. The angle between any two is the angle with 120 degrees. 120 degrees. Here inside 3 coils are rotated. What is the advantage of 3 phase over 1 phase? In 3 phase, if any one of the coil is to be failed, the other 2 are working. మిగతా రెండు వర్క్ చేస్తుంది. అవుట్పుట్ క్యాన్సిల్ అవ్వదు, కరెంట్ పోదు మనకి, ఈ రెండు వర్క్ చేస్తుంటాయి. ఇన్ త్రీ phase, if any one of the coil is failed, then other 2 are working. So, and also it has another advantage. It has a high efficient. Its efficiency is more. Why its efficiency is more? With the same energy, 3 coils are rotated. So here, with this energy of rotation of the coil, only one is rotated. Here, with the same energy, 3 coils are to be rotated. Just like, for example, ఇప్పుడు మీరు బైక్ మీద వెళ్తున్నారు, బైక్ మీద ఒక 100 కిలోమీటర్స్ వెళ్ళాలి. మీరు సింగిల్గా వెళ్తే బెటరా, 3 మెంబర్స్ ఎక్కి వెళ్తే బెటరా? సింగిల్, సేమ్ యూసేజ్ ఆఫ్ పెట్రోల్. ఓకే, 3 మెంబర్స్ same uses of petrol but sharing కదా. So this is the advantage, అంతేనా? So 3 phase is advantage, its efficiency is more. అంతే కదా. మనం బైక్ వెళ్ళేటప్పుడు ఆర్టీసీ బస్సులో కూడా ఆక్యుపేషన్ అంటారు. ఆక్యుపేషన్ అంటే ఉట్టి బస్సులు తెప్పకూడదు, దాంట్లో జనాలు ఉండాలి. అలానే ఇప్పుడు మనం ఒక్కళ్ళమే సింగిల్గా బైక్ వేసుకొని వెళ్తే మనకు ఖర్చు ఎక్కువ. అదే 3 మెంబర్స్ ఉన్నారు అనుకోండి, ఇంకొక 2 ఉన్నారు అనుకోండి, వెనక ఖర్చు తగ్గిపోయినట్టు. 3 మెంబర్స్ షేర్ అవుతుంది. ఓకే, డివైడెడ్. హియర్ ఆల్సో ఇట్స్ ఎఫిషియన్సీ ఇస్ మోర్. The efficiency is more. Its efficiency is more efficient. Okay, all these are about 3 phase. సార్ చూసుకోండి, 3 phase అంటే ఏమేమి చెప్పాను ఇప్పుడు చెప్పండి. డైరెక్ట్ కరెంట్ అంటే ఏంటో చెప్పాను. నెక్స్ట్ ఆల్టర్నేటింగ్ కరెంట్ డయాగ్రామ్స్ చెప్పాను. ఈక్వేషన్ ఏం చెప్పాను? ఈ నాట్ అంటే ఏంటి? పీక్ వాల్యూ. దానికి ఫార్ములా ఏంటి? బిఏ ఒమేగా ఎన్. బి మ్యాగ్నెటిక్ ఫీల్డ్, ఏ ఏరియా ఆఫ్ ద కాయిల్, యాంగులర్ వెలాసిటీ, ఎన్ నెంబర్ ఆఫ్ టర్న్స్. ఓకే, నెక్స్ట్ టాపిక్ నెంబర్ 5. So this is a waveform, sine wave. So this is the sine wave. IRE. So this is the sine wave. The complete wave is from A to B. This is the complete wave. A to B. AB is the complete wave. Okay, this is the sine wave. Complete wave means one positive half cycle, so one negative half cycle. So this is the complete wave. It is complete wave. Complete wave means one positive half cycle and one negative half cycle. Complete wave means one positive half cycle plus one negative half cycle. So this is the complete wave. Okay. Average value of current or average value of EMF is only defined for half cycle, not for complete wave. I average, for suppose if we are discussing I average or E average, we are considering only for half cycle. For full cycle, 0. I average 0, average current, average EMF is 0. It is always defined for half cycle. Half cycle. For suppose for complete cycle, I average or E average is only defined for half cycle. For half cycle, only defined for half cycle. Very very important. మనము I average గురించి కానీ E average, I average, average current, average EMF వీటి గురించి చెప్పాలి అంటే we have to study only half cycle, not complete cycle. For complete cycle, it is 0. For complete cycle, చూద్దాం. First suppose this is the complete cycle. I or EMF, time function. So this is complete cycle, A to B, A to B, A to B, complete cycle. Complete cycle, how to define I average? చూడండి, so this is I1 ఇలాంటిది ఇక్కడ ఒకటి ఉంటుంది, క్యాన్సిల్, ఆపోజిట్ క్యాన్సిల్. I2, so this is ఇవన్నీ ఇటువన్నీ క్యాన్సిల్ అయిపోతాయి. Full opposite, full, these two are cancelled. For complete cycle, between A and B, this is the complete cycle. Between A and B, complete cycle, I average is equal to 0 or E average is equal to 0. So for full cycle, A to B full cycle. For complete cycle, those values are 0. Direct bit. Only I average, E average, average current, average EMF is defined only for half cycle, not for full cycle. So between A and B, these are cancelled because this one and this one opposite in directions, so they are cancel each other. Both are cancel each other. That's why 0, direct bit. దీని అర్థం ఏంటి? దట్ ఈస్ ఫర్ ఫుల్ సైకిల్, they are 0. They are 0. Full cycle. That's why average current and average EMF is only defined for half cycle, not for full cycle. For suppose ఇదే డయాగ్రామ్ ఇలా అన్నారు అనుకోండి. ఓకే, సో A point, B point is here. AB. Between A and B, now I average, E average, what happens? 0. This is also taken to be full cycle. దీన్ని కూడా ఫుల్ సైకిల్ గానే టేకప్ చేయాలి మనం. ఎలాగంటే చూడండి, ఇక్కడ వరకు షేడ్ చేస్తున్నాను. Opposite, cancel. These two are equal and opposite. Here also I average is equal to E average, cancel each other. So in this diagram also, between A and B, I average is equal to 0, E average is equal to 0. In this diagram also 0. Okay, so for half cycle it is not equal to 0. I average, E average is not equal to 0. For half, దానికి డెరివేషన్స్ ఉన్నాయి, అదని మనం రాయాల్సిన పని లేదు. చూడండి, వెరీ వెరీ ఇంపార్టెంట్ ఫర్ హాఫ్ సైకిల్, వెరీ వెరీ ఇంపార్టెంట్ ఫర్ హాఫ్ సైకిల్. మెయిన్ ఫార్ములా for half cycle. So right, only we are defined only for half cycle, I or E. It is a half cycle only, half cycle. So from here to here we have to design. From here to here we have to design. This is only what is the formula for I average. So this is I1, I1, I2, I3 current, instantaneous currents, I4, so on, IN. So up to here, I average, it is equal to I1, general expression, I2 plus I3 plus and so on plus IN upon N. So this is the average current. Average current, it is only defined for half cycle. For half cycle, average current ఇక్కడ రాశాను already. I average, this is also important. I average or E average is only defined for half cycle, not for full cycle. For suppose if it is full cycle, they are zero. They are zero because cancel. Equal and opposite, that's why they are cancel each other. This is one formula are very, very important heart of this chapter. I average is equal to 2 I naught upon pi. 2 I naught upon pi. Very, very important formula. What is I naught here? Peak current. Peak current. This is I naught. 2 I naught upon pi. Okay. Similarly, E average is equal to 2 E naught peak EMF upon pi. These are the formulas. Is okay na? I average current 2 I naught upon pi. E average 2 E naught upon pi. ఇప్పుడు వరకు వచ్చినట్లు ఇవి. రేపు RMS కరెంట్స్ గురించి చెప్తాను. ఫార్ములా ఈజ్ వెరీ, వెరీ ఇంపార్టెంట్. ఏమేమి వచ్చినాయి ఫార్ములాస్ ఒకసారి చెప్పండి ఈ క్లాస్లో. మీకు ఈ క్లాస్లో మీరు ఏమేమి నేర్చుకున్నారు? DC అంటే ఏంటి చెప్పండి. DC అంటే ఏంటి? డైరెక్ట్ కరెంట్, నో చేంజ్ ఆఫ్ మ్యాగ్నెట్యూడ్ అండ్ డైరెక్షన్, అది చెప్పాను ఫస్ట్. తర్వాత ఆల్టర్నేటింగ్ కరెంట్లకి డిఫరెంట్ వేవ్ ఫార్మ్స్ వేసాను. ఆల్టర్నేటింగ్ కరెంట్ మీన్స్ ఇట్ కమ్స్ నెగిటివ్ సైడ్ ఆల్సో, పాజిటివ్ అండ్ నెగిటివ్ సైడ్. అందులో ట్రయాంగులర్ వేవ్ వేసాను, సైనసాయిడల్ వేవ్, స్క్వైర్ వేవ్, రెక్టాంగులర్ వేవ్, సాటూత్ వేవ్. ఆల్ ఆర్ సైనస్ alternating currents అని చెప్పాను. Alternating currents has an equation I is equal to I naught sin omega t. అందులో I అంటే ఇన్స్టాంటేనియస్ కరెంట్, I naught పీక్ కరెంట్, ఒమేగా టీ ఫేజ్ అని చెప్పాను. తర్వాత I naught కి ఒక ఫార్ములా చెప్పాను, BA ఒమేగా n. నెక్స్ట్, what is meant by three phase? Three phase, single phase means one coil is rotating in the magnetic field. Three phase means three coils are to be rotating in the magnetic field. What is the advantage of three phase over one phase? In three phase, if any one of the coil is failed, the other two are working. That's why its efficiency is more than Japan. What is the angle between any two coils? 120 degrees. Next, I am discussing about alternate average current and average EMF. In case of alternating currents, average EMF or average current is only defined for half cycle. For complete full cycle, they are zero, cancel. So I average for half cycle is 2 I naught upon pi. Very, very important formula. Okay na? Bye. See you in the next class.